Here we go. State the domain and range. This is Algebra II, Practice Final Exam Part D. This is our fourth and final review of me going over everything that's on the final. Should be ready to go after this. Find the domain and range. Decide if the ordered pair is a function or not. So starting off with domain. Domain means x. So for this problem, it's 2, 4, 7, and 5. Range means y's. So my y's are -3, 1, 7, and 8. Since my x's never repeated, all of them were different, the answer, is this a function? Yes, it is. If my domain would have had an x that repeated, it would not be a function. Number 2 is if x plus 2 is one of the factors. Find the remaining zeros. So that one is a 0. I got to find the rest. It is an x cubed polynomial, so I'm going to have 3 answers in the end. To do this problem, I'm going to do synthetic division. So 1x cubed minus 1x squared minus 10x minus 8. I'm writing the leading coefficients there. Since this problem is given to me as a factor, x plus 2, I'm going to change the sign. I'm going to set it equal to 0 and solve for x. I'm really putting a -2 in the box. I know that it is one of the factors, so I know in the end here I am going to get 0. Let's find out by doing synthetic division. Drop the 1, multiply, add, multiply, add, multiply, add. I get 0. Since I got 0, that means it did work like it was supposed to. It was an x cubed polynomial, so this 1 right here means x squared. It was x cubed. I'm doing 1 less than that, so now it's x squared minus 3x minus 4. To find my other 2 answers, I need to solve that. In this case, I'm going to factor. I need 2 numbers that multiply together to get me 4. That would be 4 and 1, because it needs to get me -3, so it's a -4 and a +1. Those 2 numbers multiply together to get me -4, and they add together to get me -3. My roots, my zeros, my x-intercepts are going to be x is equal to +4, -1, and -2. Those are my 3 answers here. Number 3, factor. In this case, I've got a 3 in front here, so I'm going to multiply that 3. I'm going to do borrow and payback. So I'm going to multiply that 3 over. X squared minus 4x minus 21. Multiplied by 3 to start. Now I'm going to factor. 2 numbers that multiply together to get me 21 would be 7 and 3. It needs to get me -4 when I add them, so -7 and a +3 will do the trick. Those 2 numbers multiply to get -21 and add to get -7. Add to get -4. I borrowed that 3 at the beginning. Now I'm going to pay it back. So I'm going to divide both of those answers by 3. 3 divided by 3, that reduces to x plus 1. That's one of my factors. This one can't reduce, and so I'm going to bring that 3 out in front. I'm going to multiply by 3, and so my factor becomes 3x minus 7. If you can't simplify it, we really just bring that number out in front to get 3x minus 7. Number 4, we're subtracting, and so this is a pretty easy concept. Really what you're doing is distributing that negative sign. Distribute that negative sign to each part. So over here, this stays the same. I've got a negative sign in front of those parentheses over there, so I'm really going to change all of those signs. So it becomes positive 3x, -7, and positive 5x cubed. At that point, I'm combining like terms. -7x cubed and a positive 5x cubed gets me -2x cubed. Positive 2x squared, positive 7x, and then -7 here at the end. Just combining like terms and distributing that negative sign. Number 5, we're simplifying the exponents. Since I'm dividing exponents, I'm really going to subtract them. I want to take 4, or 4 over 1, minus 2/3. I'm subtracting fractions. In order to subtract fractions, you better get common denominators. Since this one's a 1 and that one's a 3, let's change them both to be a 3. Over here, I'd have to multiply that 1 times 3. So that means I better multiply that top by 3 and get you 12. Over here, it's already a 3, so I don't have to do anything on top. It's just going to stay the same. 12 thirds minus 2 thirds is going to get you a to the 10 thirds power. I subtracted because it was division, and that a is going to stay on top because that exponent of 4 is bigger than that exponent of 2 thirds. Number 6, solve using square roots. We're just getting x by itself. Add 54. Oh, that looks super ugly. Let me try that again. Add 54. 6x squared equals 54. Divide by 6. Divide by 6. X squared is 9. And then finally, to get x by itself, I'm going to square root x is equal to plus or minus 3. Next one, graph negative 2x plus 4. It is a line. This right here is your y-intercept. So I'm going to start here at positive 4. The negative 2 is my slope, so I'm going down 2, right 1, down 2, right 1, down 2, right 1. And then I'm going to graph my line. It is a straight line. I'm going to try to do the best I can up here. Yeah, that was kind of ugly, but you get the idea. It's a negative slope, so I better go down 2 over 1. It's rise over run, negative 2 rise, and a 1 run, and we always run to the right. The plus 4 is my y-intercept. Number 8 says name the solution. It's 2 lines. The solution is wherever they cross. In this case, it's an ordered pair at negative 2, positive 2. All we're looking for is where do those 2 lines cross. It is at negative 2, positive 2. Evaluate this one. X to the third times x to the fifth, all raised to the 1/6 power. We are multiplying these two things with the same base, so all we're really going to do is add those 2 exponents together. It gets you x to the 8th power. Now I am taking that and raising it to the 1/6 power. If you're raising that to the 1/6 power, you're really going to multiply these two things. So you're taking 8 over 1 times 1/6, which is 8/6. Multiply straight across on that fraction. We can reduce 8/6. 8 over 6 can reduce to 4 thirds. And so my final answer is x to the 4 thirds power. Number 10, f and g are that. We're trying to find f of g of x. G is on the inside. So you are taking g and you are plugging it into the other one. Okay? Or in other words, you could write it like this, f of g, where g was here, so I'm going to write in what g is, x plus 8. That means instead of writing f of x, instead of writing x for the x equation, you're going to plug in for x the g equation, x plus 8. So we're going to distribute. And then I can combine like terms. 2x, 16 minus 4 is 12. I plugged in and simplified there. Halfway done. Number 11, we're multiplying. Nothing fancy here, just doing a lot of distributing. So that's going to get me 4x cubed minus 28. Sorry, can't add. 4 times negative 7 is negative 28. X squared. And then 4x times 5 would be, 20x. Great, I multiplied 4x times everything. Now I'm going to distribute the 3 to everything. So it's going to be 3x squared minus 21x plus 15. We are then going to combine like terms. The way I write them makes this pretty easy. 4x cubed minus 25x squared minus 20 minus 21 would just be minus x plus 15. I FOILed it out and then combined like terms. Number 12, solve the quadratic by factoring. So we're just going to factor that thing right there. I need 2 numbers that multiply together to get me 30. So numbers like 6 and 5, 3 and 10. One of those combinations needs to add or subtract to get me negative 1. So the best choice here is negative 6 and a positive 5. Negative 6 times 5 gets you negative 30. and negative 6 plus 5 gets you negative 1. We are solving here, so it's not just that. We need to set these things equal to 0. So when I take x minus 0, or 6 equal to 0, and x plus 5 equal to 0, add 6, subtract 5. X equals 6, and x equals negative 5. Solving by factoring. Oop, too much. Is 3 a root? So to decide if that is a root or not, we are doing synthetic division again. 1, 4, negative 15, negative 18. We're trying to decide if 3 is a root. It's not written with x, so I don't need to change the sign. I can just put 3 in the box. We're doing synthetic division. So I'm going to drop the 1, multiply, add, multiply, add, multiply, and add. Negative 18 plus 18 gets you 0. Since I got 0 right here, if you get 0, the answer to your question, is it a polynomial? Yes, it is. Or, I'm sorry, is it a root of the polynomial? Yes, it is. Remember, this was an x cubed polynomial. I'm done. The answer is yes. But it was an x cubed polynomial. So this 1 right here means 1x squared plus 7x plus 6. That's what this means. That's what you would have to solve to find your other answers. Number 14, we are solving here. So first thing I want to do is get rid of that square root. So I'm going to square both sides. 4x plus 5 equals 49. Minus 5. Minus 5. 4x equals 44. Divide by 4. Divide by 4. X is 11. It's going to work. I had no negative numbers that I squared in that polynomial or in that solution, so x equals 11 is going to be an answer. Write the equation of the line. As soon as you read write the equation of the line, you know that you're going to use point slope formula. Remember what's going to go on here? You are going to put your x values with your x. You're going to put your y values. I'm sorry. Ugh, that was garbage. Don't do what I just did. That's what happens when you teach math all day long and then try to do extra math. How about we say put our x values with our x. So that's going to go right there. We're going to put our y values with our y's. And we're going to plug in slope right there. It says the slope is 5. So that's what we're going to plug in. Slope is 5, so 5 is going to go there. Our x value is 6, so it's going to be x minus 6. Our y value is negative 3, so it's going to be y minus a negative 3. As is always, when you have minus a negative here, that's going to become positive. So y plus 3 over here. Over there, I'm going to distribute and get 5x minus 30. And then finally, I'm going to get y by itself, so I'm going to subtract 3. Minus 3, minus 3, y equals 5x minus 33. Number 15. Number 16, solve the solution. Write your answer as an ordered pair. We're looking for something easy to cancel here. This is 4x and this is negative 2x. So something that would be really easy here is if I had 4x on top and a negative 4x on bottom. Those two things would be opposite and would therefore cancel. So what I'm doing here is I'm going to take this bottom polynomial and multiply it by 2. Or bottom equation, sorry, I keep calling it a polynomial. I'm going to multiply everything by a positive 2. Because if you multiply it by a positive 2, this is going to become negative 4x plus 10y equals 8. I'm sorry, that's a negative 10y. I don't know where that came from. As I say, that's going to make this problem ugly. Negative 10y, sorry. And now that I've done that, I'm going to combine like terms. X is canceled like I wanted. 3y minus 10y is negative 7y. 6 plus 8 is 14. At that point, we're going to divide by negative 7. Y is negative 2. Once you get one number, we're going to take that number and plug it back in. It doesn't really matter which one I plug into. They're both equally They're about equal. So I'm going to plug into this top equation here. So it's going to be 4x plus 3y equals 6. So I'm going to plug 2 in for y. So try to color code that for you. Throw a 2 in right there. Sorry, a negative 2, because y is negative 2. So it's going to be 4x minus 6 equals 6. Add 6, add 6. 4x equals 12. Divide by 4, divide by 4. My final answer, it says write it as an ordered pair. My x is going to get me 3 because it's 12 divided by 4. And my y is negative 2. That is the solution to that polynomial, or to that system. Sorry, I keep saying polynomial. That's my system. That's 16. Number 17, graph the system of inequalities. Y is less than negative x plus 6. We're graphing this thing. Plus 6 is my y-intercept. My slope is negative 1, so I'm down 1, right 1, down 1, right 1, down 1, right 1. On this one in particular, it is just a less than sign. It's not equal to. So since it's not equal to, I'm not going to make a solid line. I'm going to make a dashed line. So I'm going to cheat here because it's kind of hard to write up here, but I got those dots. You get the idea of where this is supposed to go. That's not super pretty, but you get the concept. It is a less than sign. Since that is a less than sign, right there, it is telling you you need to shade below that line. So your answer is somewhere on this half of the graph down here. Now let's graph the other line. The other line says y is less than 2x minus 1. So I'm going to start at negative 1 for my y-intercept. My slope is a positive 2, so I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, and so on. Again, it is a less than sign, not equal to. So since it is not equal to, I'm really going to make a dashed line here. So dashed, dashed, dashed. Dashed line right there. There's my line. It is again a less than sign. So since it is a less than sign, I'm going to shade less than that line. So I'm going to shade below it. So I'm shading below that blue line. It's going to be somewhere on this half of the graph. So I'm looking for where did I shade both lines. The answer to that is down here in this section right here. That is the answer to this question right in that section. That's 17. 18, it's graph the quadratic. We were struggling with this the other day. It is a squared thing, so I know my shape is going to be a polynomial. My pattern, my goodness, a parabola. The pattern is 1, 3, 5. The plus 2 to find your vertex. Whatever's with your x, you're going to take that and change its sign, so it's going to be negative 2. Whatever's tagged on the end, you're going to do what it says, so it's a minus 5. That plus 2 takes you left 2. That minus 5 takes you down 5. So I'm going left 2, down 5. There is my starting dot. That is my vertex. From there, I'm making a parabola. The parabola pattern is 1, 3, 5. So from there, I'm going up 1 over 1, up 3 over 1, and then up 5. 1, 2, 3, 4, 5 over 1, up 5 over 1. There is my parabola U-shaped thing. It is a quadratic, so it's going to be a parabola. Change the sign with whatever's with your x. Whatever's on the end is going to stay the same, negative 2, negative 5. All right, going to have to zoom out on this one. On number 19, a hat company is trying to minimize cost. This is the cost for producing the hats, where C is the total in billions, and X is the number of hats made in millions. How many hats should you produce to minimize the cost? So we're trying to find hats. We're trying to find X. It is a quadratic, so it's going to be a parabola. My shape is going to look like this. I want to find the lowest point. I want to minimize it. So I'm finding the vertex. I'm using that formula, X is equal to negative B over 2A. So in this case, my B is negative 2, so it's going to be a positive 2 over 2 times A, which is 0.1. So in my calculator, I'm going to take 2 divided by 0.2, because that's 2 times 0.1. So I'm going to take 2. Let me clear that out for you so you can see it. 2 divided by 0.2. That will tell you where is the x a minimum. It is at 0.4 for my value there. So 0.4, that's my x value. Remember what the x means. The x here is the number of hats in million. So if it's 0.4 million hats, or in other words, 400,000 hats is how many they should produce. Determine the lowest cost in billions it's going to be able to achieve. That's expensive hats that they're making here. We are plugging in 0.4 in for x. So my problem is going to look like this. 0.1 something squared minus 2 something plus 24. Right here, I'm going to plug in that x value I just found, which was 0.4. So we're going to plug that in. It is 0.1. Yep. 0.1. Yeah, hang on. Try that a third time. 0.1 parentheses times 0.4 squared minus 2 times 0.4 plus 24. Type it in. Hit enter. How much is that thing going to cost? $23.216 billion. That's the cost. That's not how much they're making. Don't get into the hat world, apparently. That's expensive. Number 20 says tickets are on sale for the annual Yuletide on the first day of ticket sales. The school sold 3 adult tickets and 9 children tickets for $75. On the second day, they had 3 adult tickets and 5 children tickets, and they were sold for $67. What is the price for an adult and a child? They did the first equation. So the first equation was all kind of written together there. It said day 1 was what you're doing first. So the day 1 stuff was the 3 adults plus 9 children is 75, or 3a plus 9c is 75. We're writing the second equation. So the second equation for day 2 is this one. 3 adults and 5 children is 67. So 3 adults plus 5 children equals 67. The easiest way to solve this problem is to get 3a and a negative 3a. So really what I'm going to do here is I'm going to multiply that bottom equation by negative 1. So it's going to get me negative 3a minus 5c equals negative 67. I'm just going to multiply everything in that bottom equation by negative 1. And when I combine them now, the a's are going to be canceled. That's going to get you 4c, and 65 or 75 minus 67 is going to be 8. Divide by 4, divide by 4. C is 2. It is $2 for a child's ticket. Once I find that out, I'm going to plug it back in. So I'm going to plug it into that bottom equation, I guess. 3a plus 5 times 2 for the children's tickets is 67. So I'm going to subtract 10 from both sides, because 5 times 2. So I'm going to take 57 and divide it by 3. My A is going to be 19. It is $19 for an adult ticket and $2 for a child's ticket. Be a kid. Stuff is cheaper. Oh, later on it talks about senior citizen. Don't do the senior citizen. All right. Last one. The path of a ball can be modeled by that graph where x is the time in seconds and y is the height in feet. Find the maximum height. It's right there. Looks like 13 feet. How long does it take to reach its maximum height? This down here is the time, so it's 3 seconds. What is the height at 5 seconds? So I'm going to go to 5 seconds. Here's 5 seconds. It looks like it's right there, which is 9 feet. How long does it take for the ball to hit the ground? It started on the ground, it goes up in the air, and comes back down. It hits the ground again at 6 seconds. The end. Good luck on your final.